This is a very recent O-level question. Is last year, 2023, and it's a IV graph of diode, LEDs. The D stands for diode, so nothing new. You have seen this before. You're asked to describe how the resistance changes. So anything below 1 volt or 1 point something volt, and in the negative region, negative voltage, like a diode, it doesn't allow current to flow in opposite direction. So over here, there's no current flow. No current flow means the resistance must be very, very large. So from 0 to 1 volt, the resistance still remains very large because we see that the current flow is still 0 over here from 0 to 1 volt or 1 point something volt, 1.2 volts perhaps. Now, from 1 volt onwards to 2 volts, that's where the question is asking. You can see that the current starts to climb. So the current increases, and this must tell us that the resistance must have decreased. And that is the answer to A part 1. All right, for this question, there are two differences here. If you read this metal wire at constant temperature, we are assuming that this is an ohmic conductor of a metal wire, and the IV profile is a straight line passing through 0, 0. So that itself is one of the difference where for ohmic conductor, for this metal conductor, the IV graph is a straight line that passes through 0, 0, whereas for the green LED, it's not a straight line that passes through 0, 0. So that's one difference. Second difference, talk about the negative voltage. For the green LED, for negative voltage, there's no current flow at all, 0 amperes. Whereas for a metal wire, if you apply voltage, negative voltage, which means you force the current to flow in the opposite direction, the current will flow in the opposite direction, negative current, meaning the current flow in the opposite direction. So these are the two differences.